Okay, so the next thing that we need to really understand when we're doing this is that we're going to be talking about ratios of side lengths, and we're going to be comparing side lengths in triangles, right triangles. So what we're going to be doing, now I'm going to draw this triangle just a little bit differently so you don't think that all right triangles have to be drawn the exact same orientation. So I'm going to draw it like that. In this case, this will be the hypotenuse. I'll use HYP for short. And I need to choose one of these two angles to work with. I'm going to choose to work with this angle. So again, I'm going to put theta there, which means it's this angle measurement. Okay? And that's going to represent whatever that angle measurement. And no, we're not going to be measuring it with protractors. We're going to do all this using algebra. So this angle here, I'm going to call it angle A for lack of anything better to call it, A, B, C. And this side over here, since it's directly opposite theta, is the opposite side. And we should say opposite side to angle A, but we don't. We get lazy, and we're just going to call opposite. And this one over here, we're going to call adjacent. And again, we could call it adjacent side to angle A, but we don't. We get lazy, and we just call it agent. Adjacent, sorry, not agent, adjacent. And the short form for adjacent is ADJ. The short form for hypotenuse is HYP, and the short form for opposite is going to be OPP. Okay? So, and this isn't adjacent, this must be hypotenuse. Okay? It can't be anyone's adjacent, it is always called the hypotenuse. And what we're going to do is we're going to talk about two ratios. And the two ratios are, we're going to take the opposite side, we're going to take that length, so whatever this length is, and we're going to divide it by the hypotenuse length. Okay, so those are going to be two numbers. So we're going to be measuring this length, we're going to be measuring this length. We're going to take this length, we're going to divide it by this length, and we're going to call it something. We're going to call that, I sort of ran out of room here, but we're going to call that the sine ratio. And we give it an unknown. Now, that's the proper way to write it. So it would be sine of angle A, which is the way we should write it, but we never do. The short form is always sine of angle A. And sine of angle A is equal to the decimal that we get when we do the opposite side length divided by the hypotenuse side length. Okay? Another way that we could write this is sine of angle A. So we could put the symbol there for angle in there. And again, it would be opposite side length over hypotenuse side length. So what's going to happen here is we're going to get a measurement up here. We're going to get a numerical value. We're going to get a numerical value down here, a number and a number. They're going to divide, and they're going to give me a decimal number. And that is going to be the decimal number that we get. And it's going to mean something to us. It's going to represent that angle A in a very real fashion. The other ratio that we're going to be looking at is cosine. Now, cosine, let me just draw this triangle just a little bit different. And again, I'm only doing that so that you understand that I can change the orientation of right triangles. They don't always have to be the same way. This will be hypotenuse. Let's talk about this being my unknown angle that I want to reference. I'm going to call it A, angle A again. So this would be the side opposite angle A. This will be the side adjacent angle A. This must be hypotenuse, it's always opposite the 90. And there's a new ratio that we're going to talk about, and it's called cosine angle A, and it's given by the length of the adjacent side. So it's the adjacent side length divided by the hypotenuse length. So it's going to be whatever we measure this to be divided by whatever we measure this to be. And that's cosine. Now that's the full name for it. We're going to shorten it because mathematicians like to be lazy. It's going to be cos. Now it stands for cosine. Don't call it cos. It's cos. That's the shortest we can make it. So cosine of angle A will equal the adjacent side length divided by the hypotenuse. Again, this is going to be a numerical value. This is going to be a numerical value. They're going to divide to give me a numerical value with a decimal, and that's what that number is. And it's going to tell us something very distinct about the reference angle. Okay, I'm going to stop there, and then we'll do the next video.